Hello AS Math students, it's Mr. Knight here. We are continuing our quest of integration and our quest to take over the world through mathematics one step at a time. Today what we're going to do is we're looking at the area between two curves. We have just up to this point have been looking at the area underneath a curve. But what if I'm presenting you with something like this? We have two functions. I got f of x and g of x, and sandwiched in between is this nice little area that we'd like to find. And actually, it's not too much different than what we've been doing, but we got to put a little bit of thought into it. So, given these curves right here, what we can think about is think about them as like separate curves right now, and think about just finding the area under just one of them right now. Well, if I found the area underneath this curve, and let's say we go from here to here, let's go 1 to 3, where our bounds look to be, right? If I go from this area, I'm going to get all of this stuff underneath, including like some of this stuff over here and here. But it does include this blue area. Now, if I go ahead and get the area under g of x, well, that's going to give me this area right here. This stuff as well, right? But it doesn't include this shaded area. So what we can do is, if I get the area of f of x, and then I subtract off the area of g of x, well, I should have this area left over, and that's pretty much what we're going to be doing. So when we set this up, this is how we set up our integral. We still have the same integral from a to b, from our bounds on the x-axis, and we're just going to take our top function, whatever it ends up being, whatever the top function is, and subtracting off this function. And then we're going to integrate that. So it's not too much different than what we've been doing, but it's just a little bit more thought and conceptual understanding with it, okay? Now, the thing is, we need to find our bounds. We're usually not given bounds, okay? Even in this problem, we weren't given bounds, but we can kind of look at them and see. So we can see that 0 and 3 look to be the bounds. But what if you weren't sure? Well, to find our bounds, we can just see where they intersect, so we can set those curves equal to each other and solve for x, and that's all we got to do. So with these curves, I'm going to go ahead and do that. It should be 0 and 3. Let's see if that works out. Spoiler alert, it does. Of course it does, right? Of course it does. So I got my two functions. I set them equal to each other, and here are the steps I take to solve for the x values. And I do find out that, yeah, x is equal to 0 and x is equal to 3. So my lower bound a is going to be my lower number 0, and b is going to be my 3. So nice, I have my bounds, and I can start setting up my integral. Well, my f of x, or my top function, was the red guy, minus my green function, which was the bottom function. Now, what's really critical here is putting these guys in parentheses. It doesn't seem like a big deal, but because I'm subtracting right here, I need to keep in mind that I need to distribute this negative sign, so all my signs are going to change. I have negative x squared plus 2x minus 1. And then I can combine some like terms, and I end up getting this integral right here from 0 to 3. And we can integrate that using the reverse power rule. We go ahead and we do that. I end up getting this function back. I'm evaluating from 0 to 3. So I plug in 3, and I get these values, minus, well, when I plug in 0 to this guy, and obviously that's going to be 0. I simplify this out a little bit. I can turn this guy into 18 over 2, and so I'll end up getting, when I subtract, 9 half units squared. And that would be my area between those two curves. I know that was a quick example. Let's see one more, taken actually from your exercise 6D. This is number 2 from exercise 6D, and we're tasked with 3 different things. So this is more typical of a problem that you'll see. So it tells us to sketch these curves, y equals x squared plus 3 and y equals 5 minus x squared, on the same axes, and then we're going to shade the enclosed region. Okay, so we're going to have to set up some kind of xy table and kind of do it that way. Part 2 actually wants the coordinates of the points of intersection. That's not going to be too bad. Again, setting them equal to each other and then solving for x. But it does want the points, so it wants the y-coordinate as well. And then part 3, find the area of the shaded region using integration. Okay, so here's our solution. What I decided to do, I kind of combined parts 1 and 2 together. Oops, right? But they kind of work really well together. First of all, if I want to actually sketch those curves, it'd be a nice idea to figure out what x values to plug in. Well, what better x values than your bounds, right? So let's find those first. So this is really part 1 and 2. So I set my equations equal to each other like this, and I focus on that. Rearranging this guy, I solve for x, and I find that when I take the square root of both sides, x is equal to -1 and 1. A will be my lower bound, b will be my upper bound. Nice. I found my bounds. So those are actually going to be part of my graph. All right. So I'm going to set up two XY tables for these guys. I'm going to sketch them separately and then figure out what the area is. Okay. So I started plugging in some x values. Notice I plugged in one of my bounds right here, one of my bounds right here, and I did it for both these guys. So we can see that the bounds, and I'm going to kind of cheat a little bit, are just going to be these guys right here. So for part 2, one of our coordinates is -1, 4, and the other one's just going to be 1, 4. There we go. We found that by plugging in the x values into our functions and getting the y values back. But I plugged in additional x values too. Again, I want to sketch this guy. I want to know what it looks like. So I tried easy values 0, 2, -2, and these are the xy tables I got. Now, sketching them on my graph wasn't too bad either. I found that enclosed is this little guy right here, and I got to shade that region. And boom, shakalaka, boom. Part 1 and 2 are done. Okay. So we got to find that area, and we know that one of our bounds is -1, the other one's +1. That's where these guys meet at these points right here and right here. All right. So let's set up that integral. Now, what's our top function in this case? Well, our top function's got to be the green function, right? It is the top part of this enclosed region. And I have to subtract off the area of this bottom curve right here. Okay, so green minus, green minus red, basically. Okay. So this is the integral that I came up with. Here was my a, here was my b. My top function, the green function, was 5 minus x squared, the one that was opening down, subtracting off this one that was opening up. And it actually was a really, really nice integral because when I simplified this, I got -x squared minus x squared. And those guys do not end up canceling out. Oops. Okay, I left my error in the video. I'm not even going to edit it just so you can see. Dude, I mess up sometimes. Okay, this part's wrong. And you, as soon as you heard it in my voice too. Exactly. So the x squareds, they actually should not cancel out. That was my bad. All right, let's reset this guy up. Okay. This guy, when we open up the parentheses, we're going to end up getting -x squared minus 3, just like this. Okay. So if I simplify this guy out a little bit more, I'm still going to get 2 right here, but I'm going to get -2x squared right here, dx. All right. Well, now I would like to integrate that finally. Right? Oh, man, I really wish it was 2. I was so happy about that, man. And we're going to do the reverse power rule on this guy. So this guy's not too bad. That's just going to be 2x. This guy, well, okay, my reverse power rule, I got to add 1 to my exponent. And then I need to put it 1 over 1 plus 2. So that's 1 over 3. And 1 over 3 times 2 is just -2/3. And there we go. That guy's integrated, and we're integrating from -1 to 1. So let's plug some stuff in. So when I plug in 1, I'm going to get 2 minus 2/3 minus. Now I'm plugging in my -1. I get -2. When I plug in -1 and I cube it, it's going to stay negative. So I got a -1 times a -2/3, so it's a +2/3. Let's clean this up a little bit. I can change this guy to 6 over 3 minus 2/3. And I can also change this guy up to the same exact thing what I just got. That's -6/3. All right. Cleaning this guy up, we get 4/3 minus. We end up getting -4/3 right there. And since we have a minus minus, we end up adding those guys together. So my answer is positive 8/3 units squared, which is a grosser answer than 4, but it's more correct than 4. So I hope you enjoyed my little slip up. Happens to me too, man. Math is hard, and that's okay. That's why we show our work, so we can go back and fix our mistakes. This is Mr. Knight, signing off. Have a great day.